Hi everyone, my name is Rebecca Flicher, and for this video presentation I was assigned section 1.6 number 13. So the question says to find the general solution of the differential equation, and we were given x times y prime equals y plus the square root of x squared plus y squared. So the first thing we want to do to solve this is to get y prime by itself, because y prime is the same thing as dy dx, and to solve this we want to get that by itself. So the first thing, as I said, is to get it by itself is to divide both sides by x. As you can see, I did it there in blue just to make that step pretty clear. So after you divide by both sides, you get y prime, or dy dx, is equal to y over x plus the square root of x squared plus y squared over x. So the next thing we want to do is get our relationship between our y and our x to be the same, so that way when we do our substitution later, it makes it easier. So to do that step, we want to remember a couple things we've learned in class and from other assignments we might have done in the past. And that's these two things you see here in red and in green. In red, it shows how x is the same thing as the square root of x squared, which is kind of important because we're going to have to use that relationship to make sense for how this problem works. And then the thing in green says that the square root of a over the square root of b is the same thing as the square root of a over b. These are both really important things you're going to see happening in a minute here. So the first thing we want to do is to get this relationship to look similar to sort of like this relationship. So to do that, we want to make our x be able to work with the square root sign to make it go under the square root. So to do that, you have the square root of x squared, which is what we talked about is the same thing as x. So all we're doing is changing how it looks. We aren't changing what the value actually is. So the next step to this is that you want to get your x squared under the radical sign as well, so we can actually end up simplifying it. So as you can tell from that relationship we had in the green over here, you actually end up getting the y over x plus the square root of x squared plus y squared over x squared. So now that it's under the radical, we can do some simplification. So the intermediate step is right here, where because you're adding it, you can actually split up the x squared and the y squared. So you get x squared over x squared and y squared over x squared. And then from that, we can actually simplify it one step farther and get y over x plus the square root of 1, because x squared over x squared is the same thing as 1, plus y over x squared, which, as you can tell, is the same thing as our y over x. So now we can actually do some substitution. So from what we have right here, this is actually what our f of x is, so that's what our function is going to be. And now we can actually do the substitution to find what our equation will be. So some equations we'll be using for this substitution here are v equals y over x. So that's what we're going to plug in for our v when we do the rest of the equation. And then one thing you also want to know is y is the same thing as v times x. So if you're plugging anything for y, it'll be v times x. And then we also have to find what the derivative of y is, or like what dy dx is. So the way you do that is you find product rule of this relationship right here, and you end up getting v times 1, because 1 is the derivative of x, and then you get x times dv dx. So that will be the derivative there. So you end up getting dy dx equals v plus x times dv dx. So as you can tell, the dy is in a light green and our v is in a purple, and it makes it easier for when we see the rest of the equation. I just pointed that out so we can make it easier. So our original equation is this dy dx equals y over x plus the square root of 1 plus y over x squared. So I underline this in our green, I underline this in our purple, because we're going to end up substituting that in the next step. So we substitute it, and for dy dx we actually have our v plus x times dv dx, which is equal to our v, which is substituting the y over x, plus the square root of 1 plus v squared. So now we want to do is subtract the v, because we want to get this dv dx by itself. Or we want to be able to separate the variables here. So if you subtract v from both sides, they cancel each other out. So what you're actually left with is x dv dx equals the square root of 1 plus v squared. So now you want to separate v and x here. So you have 1 over the square root of 1 plus v squared dv equals 1 over x dx. So now comes the fun part. We get to integrate it. It's in light blue here because I really like light blue when I integrate because it makes it more fun. So over here I have these little relationships again. We'll get to that in a minute. But right here, when we integrate it, we get the natural log of the square root of v squared plus 1 plus v as our antiderivative for the v side. And the antiderivative or integral for the x side is actually ln x plus ln c. And actually using a product rule here, which is ln a plus ln b, will actually give you ln ab. So we can actually apply that to over here. So you end up getting ln x times c. So that makes it easier when we're solving. So the way to get rid of that natural log is to bring it to an exponent there. So when you take e to the natural log, they cancel each other out. So what you're left with is the square root of v squared plus 1 plus v equals cx. So now what we're going to do is we're going to end up plugging back our yx back in. So now we can actually solve for our equation. So when you plug in our y over x for our v, you end up getting this right here. And as you can see, we have to try to get it back to look more like how the original equation was. You want it to look more clean and more concise here. So that's where these relationships come back in, because we're actually kind of reversing what we did in the first place. So when we had 1 here, that was the same thing as x squared over x squared. So now we're having that step, and then we go to over here. You have the square root of y squared plus x squared over x squared, because both our y and our x are going to be over our x squared here. So then you have this part right here, and then simplify it again, and you get the square root of y squared plus x squared over the square root of x squared plus y over x equals cx. So as you can tell, I circled right here in red because we did this step right here. So then you end up getting x by itself, because the square root of x squared is equal to x. So you get the square root of y squared plus x squared over x plus y over x equals cx. Now we could get rid of that x because it's on both here. So if you multiply both sides by x, you end up getting the square root of y squared plus x squared plus y equals cx squared. Now if you flip that around, so you have your cx squared on the left side, you actually get the answer c times x squared equals y plus the square root of y squared plus x squared. And that is how you solve this problem.